valence shell electron pair repulsion. Why is that bold? We haven't even talked about that.
Do we have to know that?
No.
Alright. Welcome, Jamie. And welcome, Quinn, if you end up watching this as well for it. Alright, go ahead. They are reviewing pages 136 to 143. So if you want to review that as well, I'll go over and check homework. And then we'll talk about the lab as well, to where if you're confused about something, how to fix it. Alright.
Why didn't I do this?
You know, things like Arnold's movie.
Number 3. I did not know. I looked over and over and over and over and over and over, so I was like, okay, I'm just gonna put that on there because I'm gonna put it on there.
Okay, I'll take it, but try to figure out as best you can for it. That's better than leaving it blank. Thank you for being honest. But don't, like, just try it as best you can. Even if you have no idea what you're doing, try to put down what you think it might be referring to, because you might be right. Alright, let's go over the homework report. Again, that section makes more sense once we watch the lab, which hopefully we can either watch it today or tomorrow, because it's really hard to visual a 3D substance like that, and so it's really hard to draw on the board in the book. Try as best you can, but it's so much easier just to watch the lab whenever they actually have like the foam packing models and actually build it so you can actually see it. So much easier in that section. Alright, so it's over. The homework is on page 151.
This is the first time I've actually done 2 full lines of homework. Holy cow.
Yay, Chris. Alright, so looking at it, differentiate between a, no, that's the wrong section, excuse me. Go over to the correct.
Differentiate between amorphous and crystalline. Is what the first one was.
Yep. I'm looking at a different page, sorry. Differentiate between amorphous solids and crystalline solids and give an example of each. Alright, Chris, would you like it?
Sure.
Yeah.
Amorphous are randomly arranged, such as tar, and crystalline are in a regular pattern, such as diamond.
Yep. Okay. Yeah, no diamond pattern. Now, do you remember what type of special thing? Because remember, diamonds are covalently bonded, so they're also an example of something else as well. Do you remember?
Certain pattern.
It has to do with the covalent bonds. Do you remember? It's been a while.
No.
Alright, Ethan, do you remember?
I don't know.
So a diamond is an example of a crystalline solid, but they're also an example of what type of special repeating pattern of covalent bonds. Remember we said diamond and quartz are the examples for them?
I know covalent networks.
Covalent networks, good job. That
That's
is
not
it.
going to be on the quiz, is it?
Not today, but keep in mind your exam's coming. It's one of those, if you don't know today, but just making it up for the future.
Even exam?
What?
Alright, number 2. What is a unit cell? Alright, Ethan.
A unit cell is the simplest repeating unit in crystal.
Good job. Now keep in mind this sounds very similar to something else. If you're talking about ionic compounds, what do we call their simplest repeatings, like units? We don't call it a unit cell, we call it something else. Do you remember, Chris?
No.
It's okay. Ethan, do you remember? It's okay. Now remember, formula unit has to do with the idea of it's that simplest repeating pattern over and over and over again. That refers to specifically ionic compounds. This refers to generally crystals. Alright, number 3. What type of close packing unit cells do most metals assume? Alright, Ethan, so again, we'll talk about this later on for it. What?
He did that one.
I know he doesn't, but I'm explaining it to Ethan. I'm going to go over your answer in a second, because I believe your answer was correct from whenever I glanced over it. That's the reason why I'm talking to Ethan for it, because I believe you got it. So, this is whenever we're talking about what type of close unit packing cells do most metals assume, so they're all locked in.
I understand that.
It's okay. It's the idea of how are they arranged so that way they're taking up as much space as possible. Kind of like whenever you pack your suitcase, you just throw things in willy-nilly, or do you pack it organizedly?
I just throw it in there.
You start in willy-nilly?
Me too.
Oh, okay, never mind then. Alright.
Those metals, you don't care. The metals mostly assume a hexagonal close packing pattern.
Good job. Or you can also say the cubic close packing, the face-centered one. Again, if we have time, hopefully today, to watch the video, we will, because it makes so much more sense once you see it in the 3D model. See of, oh, that's what they're trying to show on the page. So it's so much easier once you see it in that way. Alright, number 4. In what ways does a liquid crystal have that characteristics of both a liquid and a solid? Ethan.
Liquid crystals contain phospholipids or whatever.
Phospholipids.
And that's like the liquid part, I guess. And then it acts as a LCD display in computers and phones and stuff. So
Alright.
solid.
Both of those are examples examples of it. We're gonna talk about the LCDs probably tomorrow, honestly. But phospholipids, that's what your cell membranes are made of with. The idea it has properties of both a liquid and a solid. So what would be the properties of a liquid and a solid? You gave examples, but
I
those are.
said liquid crystals are still narrow and have three-dimensional order.
Yeah, okay. The book talks about that as well, but it's the idea of they have ordered arrangement, but they're not locked in. They're still flexible. With the idea of, your book even describes it as soap bubbles. How many of you have blown bubbles like with dish soap before? Like you've actually made it?
I thought I did that and you blew it in my face and I threw up.
Really?
So, I don't know, so he blew a bubble and, like, dead in my face, and, I guess I swallowed some of it, and I threw up everywhere.
I'm sorry.
I was like 7.
I'm sorry.
It's the worst moment of my life.
I'm sorry.
Worst moment of my dad, never mind.
Alright, my sisters and I, we could get hand soap and
I
we
did that.
could do it on your hands and blow through like a ring and you can blow bubbles. You could actually get a decent, don't try this here at school and make a huge mess.
I'm gonna go to the bathroom.
It's
Can I
not
use
the-
my freak?
No. But it's one of those you can, if you get it right, if you get it thick
I
enough,
do it all
yeah.
the time.
No, just don't make a mess here and don't show a whole bunch of little kids, they're gonna make a mess either. So if you can do it.
They get the
you can
mess, so let's do it.
Don't be bad influence.
Don't be bad influence. Don't call little kids stupid either.
Well,
I had a crying child yesterday.
Rick
Alright.
from what?
Fun, morning care.
Oh yeah. They
I
call
don't-
the kid thought I
this
called
is
him
why I
stupid.
hate children.
It's
The
okay.
kid thought I called him stupid even though we were talking about something way
He
different.
didn't know, but keep in mind that for a lot of little kids, stupid is a bad word, so that's probably the reason why you gotta be careful
I
around
thought we
them.
were calling them stupid.
Yeah.
Yeah, I know.
Who?
Alright.
Who?
Nope, nope, nope.
Doesn't
I
matter.
mean, I'm recording, so I can't talk about
As
it.
a little kid.
Alright, yeah, with a little child. Alright, so let's go ahead and let's review. So if you have your lab, let's go ahead and let's look at it. So Jamie and Quentin, if you're watching this as well, let's go ahead and let's talk through that one. And now, keep in mind, for that first column, what do we call it whenever you're actually drawing on the board and draw their shapes? Your book just says structure. What's the technical name for it? Newest structure. Anyone have any questions about how to do that? Keep in mind, you want to draw like your dots around the central one because it makes it more obvious. Like for that first one with ammonia,
I have questions.
you don't want to draw it just like this because this looks like what shape?
Trigonal planar.
Planar. And so because of that, you want to draw the 2 dots saying, okay, there's a region of unpaired electrons. So now what shape is it?
Trigonal pyramidal.
Yeah, so that's the reason why you want to be careful and say, okay, how many dots am I drawing around? Plus, each atom only wants to get how many electrons, Ethan? Typically, like what rule says they only want to get 8? Sorry, they want to get how many electrons? Yes. So, for something like this, what type of bond? So, carbons are off with how many?
5, 4,
3,
4.
2, 1.
Alright, so how many more does carbon need to be happy?
2,
So I'm gonna give it 6. How many more?
4.
4. So what type of bond will carbon form up?
A layer.
Okay, that's the shape. What type of bond?
is immeasurable. My days are
Bond. What kind of bond?
What type of bond? Okay, so it has 4 electrons. So how much does oxygen start off with? Okay.
6.
Alright, so how many more does oxygen need to be happy?
2.
2. So what type of bond will form up between each oxygen and carbon?
Oh, a polar.
Okay, yes, it will be polar, but
I don't
like,
know, but
what type of bond?
double. Oh
Double.
yeah.
So it'll be like that. Alright, so as a side note, you kind of partially addressed this. So oxygen wants it more than carbon. What do we call that, Chris, whenever an element wants it more than another one?
What does it start with?
E.
E?
I've gone over this so much.
Electronegativity?
Electronegative. So each oxygen will be slightly negative. Now keep in mind that if you draw the lines here, that means each carbon's electron is bonded there. So you don't have to keep drawing dots around it.
So how do
because
you
it's
know
always being
it's a double bond is because that oxygen needs 2 and it's taking 2 off the carbon. That's how it's a double bond.
Mhm.
Okay.
Now keep in mind that it's technically they're still sharing. So carbon's electrons.
Can we
are
just talk
still
about
here.
the fact that the reason I didn't get 100 was because I forgot to put dots on 3 of them?
Yeah.
You wanna see mine?
I thought you said we didn't need to put dots.
No, I said you need to put the dots. You did it on some of them, just not all.
Look at these dude.
You gotta draw your dots. Alright, so, Chris, back to your question, because you were asking about this earlier. Okay, so do they have polar bonds between carbon and oxygen?
Mm-hmm.
Okay, is this a polar molecule?
Mm-mm.
No, you're right. Why?
There's no, like, negative sides.
Yeah, it's the same on each side, so because of that,
So, like,
it's like being negative
If
and
you were to
negative.
put 2 dots above C, put 2 dots above C, it wouldn't work, but just put 2 dots
Okay,
above
we'll
C.
say like in theory, this would not happen, but
So
in
that
theory.
would be polar.
Yeah, because this would be a different type of negative, because the odds of them being the exact same negative is too slim.
Ethan, what shape is that?
Okay, this shape does not exist. Okay, what shape is this though?
Linear.
Linear. Alright, let's do,
Was I really going to say that?
let's do
Dark
this
man.
one.
That's
That's bad. We'll draw it like this. Nope, we're gonna draw it like this. Alright, so, how many does sulfur start off with?
4,
Okay.
5,
So can I do one?
6.
Okay, so
Okay.
1, 2, 3, 4, 5, 6. Alright, so, what type of bond goes here?
A single bond.
It is a single bond, so is hydrogen happy?
Yes.
Is sulfur happy?
No.
Yeah.
Yes, it is. Alright, now, would this bond between hydrogen and sulfur be polar or non-polar? Polar.
Can I say what
Now,
shape it is?
what?
Can I say what shape it is?
It's a retarded butterfly.
Alright, so, would this whole molecule though be polar or non-polar?
Polar.
Why?
Because there's 2 negatives. There's not the same order.
Yeah, so there's two negative regions, this would be partially positive. Alright, Ethan, you make it the shape.
Hang on.
Ted looking extra thick today.
Angular, what?
Ted looking extra thick today.
Okay, make sure you're not getting too distracted. Alright, anyone have any questions though about this?
No.
Anyone have any
Sounds pretty
questions
good.
about how to solve this type of thing?
9.
Alright, so is that answer your question about the rate of how to tell if it's polar or non-polar molecules?
Yes.
Awesome. Alright, okay, so let's go through and let's review with these really quick. We can play dart games as long as you don't remember kind of quick and you aren't getting too distracted. Don't let me forget to take Jamie and Quentin off the ceiling winner.
Well, it's not so much.
I'm returning just in case he decides to watch later.
I'm casually singing the Drake and Josh theme song over here.
As long as you're singing quietly, so you're not distracting other people, and so that way, well, they can hear you much better than they can hear me. Maybe just film it. Alright, we'll start. Did I start with
Oh,
Chris
it
yesterday?
burns. You started with Quinn, actually.
Okay, we'll start with Chris then. Alright, Chris, thinking back over it, let's see, we already asked what do we call this? So, thinking back over it, what do you call it if you have electrons that are not locked in? What do you call the electrons?
Homeless shelter.
What do we call them, Peru?
Delocalized.
Good job.
Take me a second. That's pretty.
Okay, not, don't get too distracted. I'm gonna move my desk back.
18.
Alright,
Shooting
what do you
shotguns.
call the situation, Ethan, whenever you have the electrons being shared by more than 2 atoms? That looks painful.
Delocalization.
Delocalization or resonance, your name.
Which is what I'm going to be doing for 5 years of my life. Excuse me.
Yeah.
No, Chris, no. Resonance.
13.
Not bad. Alright, what do we call, I'm gonna bring this down slightly.
With no Quinn, I can win.
Yeah, what can't win
Alright,
today.
what do you call this type of shit? Oh, you can just space, just got on it.
Tetrahedral.
We'll move it over. Alright, it is tetrahedral. Try to do it so Jamie and Quentin are still safe.
Kobe.
Very nice.
Kobe.
14. It went from 9 to 14.
Don't win today just because Quinn's not here.
Alright, what do you call this type of shape? So there's 2 bonding situations and 2 unpaired electrons. Angular.
What was Chris's question?
What's this one?
Well, oh, that's linear.
No, yeah, what is it?
That's not angular. That's tetrahedral.
Tetrahedral.
Wow.
Barely. Alright, what do you call this one where there's 3 electrons and then a region of unpaired electrons?
What am I saying?
No more.
Tetrahedral planar? No. Tetragonal.
There's 3.
Tetragonal. What am I saying?
3.
Trigonal pyramidal.
Trigonal pyramidal.
Brick. Brick.
Is that supposed to do something? Is there a reason you're saying that?
That's literally
basketball.
That's all. That's close to what I'm saying, isn't it?
When the
It's predominantly
ball hits the
residential.
rim and it makes that noise, people say brick.
Oh, okay.
Brick.
Hey, look, just because I shot 4 for 89 yesterday does not mean I'm bad.
Alright, What do you call this substance? What do you call this type of molecule?
Fly, floating,
Wait, what did I get?
Here we go. Try going with planner.
Did I
I
get
did
10?
not pay
I
attention.
think I got 10.
Yeah, 10.
Did I ask though? No.
You did.
You clown. 20. I don't want it to fall. I'm not gonna do it. That's one.
It's still time.
I didn't want it
Alright,
to fall.
what is the shape?
Linear.
Cool.
One.
Alright, so if I have this substance, is it almost always polar, non-polar, or it can be both?
Polar.
It is almost always polar because it would be unaltered electrons.
So if it would stick to your ear. Prussian. Prussian.
Alright,
You.
so this one,
Polar.
yeah, almost always polar.
I might want to sit down.
Like dark ball.
As long as you do it quick.
Brett.
Grab some more board.
What is
Alright,
that? 8?
Yeah, that's 8.
alright, tetrahedral, Ethan. Is that one polar, non-polar, or can be both?
Can do both.
It can be both. Watch out. You get different for touching your face?
Huh?
You touched your face.
Did I really?
Yeah.
11. My number.
Alright,
There's already
Linear.
subtexture right here.
oh, you can get grab some then. Linear, polar, non-polar, or can be both?
Not polar. Technically it can be both.
It can be both, yeah.
Most time polar, or not polar. I like the cut G. Where's the other rep?
You're.
Are you being nice?
Yeah.
Let's not do that again.
Toby.
Alright, what did I skip? I skipped this one.
How many points you got?
I don't know how to add them.
Alright, this substance, polar, non-polar, can be both.
Can be both.
It can be both, depending on how it's bonded.
Okay, I'll get that. I'll take that.
She's looking at the quiz.
I'm making sure it's done.
17.
Alright, so let's say
Big numbers.
we have this substance. Nope. We're gonna break this down. Alright, so I'm gonna pull it down. Here. You might scoot over a little bit because you were like smack dab in the middle of the screen. Like smack dab. You have to like actually get out of the aisle. Thank you. Alright, so if I have this substance, what type of bond is between boron and
Single.
okay, no, okay, it's like polar or non-polar.
Polar.
Polar, good job. Good job. Don't go back to Kevin.
Go. It's like a basketball shot.
Alright, so for this one, fluorine is
Oh, that's
making
crazy.
boron.
That's crazy.
Nah.
Imagine that.
Nah. So fluorine is making boron basically share right now. So is boron happy?
Yes.
Boron's happy?
No, I can that.
Boron's not happy. But what type of shape is this?
Felt that.
Try.
What are you looking at?
Trigonal. Plan.
Planner. This fluorine's basically forcing it to do it. Why is it? Oh, I see what that is. Oops, sorry, Ethan. YouTube saw you.
Really good.
They saw me a lot.
Yeah, I'm sorry.
10.
Alright. Oh my
You
god.
get that one.
No.
Alright, so what'll be the charges?
Okay,
I like the
Okay.
cut G.
I need you. We're gonna just slide it. I'm sorry, Jamie Clinton. You're moving all over the place for a minute.
ow.
Chris just walked into my shot. Ethan just walked into the shot. But y'all need to pick. Wait, you didn't answer your question yet.
You're about to stop rolling
Scoop.
and back up too.
Because I have to show them the board, so that way it's fair for them. Shoot. Alright, scoop that direction. Do not turn around, Ethan. Alright, so what type of charge will fluorine have?
Polar.
A charge, like positive or negative. one are technically sharing. So because of that, which one wants it more? Fluorine. So which direction will most of the electrons be pulled towards? Fluorine. Alright, so would this be polar or non-polar though?
Polar. Non-polar.
Non-polar because they're the same all the way around. Okay, wait. Now it's safe. Okay, go.
Kobe.
Ooh. Sorry.
He threw it up there on purpose. 17.
Alright.
I like to cut, G.
Don't hurt my backpack. I'm worried you're gonna like clunk it into it. Alright.
Get away from my seat, G.
Alright, so Ethan, with this, alright, so between the nitrogen and hydrogen, what type of bond is that? Okay, single, but like polar or non-polar?
I don't know. Power.
Polar. So what will be all the charges of all the hydrogens?
Negative.
Positive. Alright, so would this substance be polar or non-polar? I think it's not there.
Polar.
Why?
Because of,
Why?
Yeah, why would it be polar?
they're not the same. They're positive.
Yep, so there's positive and there's a negative
I
reason.
got my ticket for the
Pretty good addition.
phone.
Alright,
I'm the hunchback of Notre Dame.
or Quasimodo.
Huh?
Or Quasimodo.
What in the world?
I'm sorry.
Alright, cool. So questions?
Alright, so what's the main reason as to why this one? Okay, do it for a second.
Ooh!
I'm sorry.
Dude, every time.
Alright, what's the main reason why this one is non-polar and this one is polar?
Because there's two
What?
dots
Stop,
on
stop,
the There's two dots on the one.
Okay, so does this one have all of its charge distributed evenly?
Yes, yes it does.
Does this one have all of its charge distributed evenly?
No.
No, that's the main reason why. Go.
Back up. You're too close.
No, I'm not.
There you are. You're on the line.
Right here.
What is this line?
The other day it was over there.
I look at that, sorry, it's not.
Ouch!
Kobe.
Look at that, that's 18.
8.
Apologize for accidentally bumping your hand.
I'm filing for assault.
No. Are you okay though, for real? Okay, good, just making sure. Officially did not mean
I'm
to.
not a cook.
Just want to make sure, because you never know, some people in 10 years from now are gonna come back and be like, this happened in class. No, you did not, I'm sorry. Alright, so, I think we've covered pretty much everything. Does anyone have any questions about how to do this? Oh, you know what, we'll go back a little, we'll go forward a little bit, because I talked about intermolecular forces, so we'll keep going. Alright, there are 3 different types of intermolecular forces. What's the one that's in all molecules, Ethan?
London.
London, all of them.
I got my ticket for the bone round. What are trials on fucking with?
18.
Ooh, let me look at it.
Predominantly 18.
There's predominantly. But
It's
very.
either 18 or 4, so.
Predominantly on
Alright,
18.
what is the one that's caused by the shifting of the electron cloud? So as they're moving, they're gonna be on one side or the other.
Start with the D.
If you have Lennon force, dipole-dipole, or hydrogen bond.
Hydrogen bond.
Final answer?
Yes.
No. Ethan,
Say the question.
what do you call?
I have my own.
Okay. What type of intermolecular force is it? It's caused by the shifting of the electron cloud. So just randomly move.
Dipole.
Final answer?
London.
Final answer? Final answer. Yes, it is London. Come through.
I put vodka in my hand sanitizer.
Don't do that.
Actually,
Besides,
there,
that's super dangerous.
there actually is vodka in hand sanitizer. Is there?
I think you're thinking of alcohol.
Hold on.
Like it's alcohol based.
That's on the line. It's on the
I remember when COVID first broke out and they were literally making
It's on the line. It's on it.
Ethan, I give you the other one for being dominantly on one side. I can't endure
I remember back when COVID first started and they were making hand sanitizer in alcohol, like companies, like alcohol factories. Cause all the hand sanitizers would smell like alcohol. Cause my mom bought one
Ew.
and it smelled like chocolate rum.
That's kind of gross.
It
Alright.
was horrible. Like I did not use it. I was like, Mom, I don't want to smell like this.
I don't know if I want to either. Alright, so what is the one that's between polar molecules? Dipole-dipole. Keep in mind one is there too, but dipole-dipole's stronger, so type 5. It does, but I don't know.
basically correct side one.
Alright,
yeah.
what is the strongest type of intermolecular force?
Hydrogen.
Just hydrogen?
The hydrogen bomb.
Hydrogen bond, that's the only for it.
I have 86, so I don't know if you won.
Yeah. Especially when I get this 50 right here. Okay.
What do we, so, if you're gonna have a hydrogen bond, hydrogen has to be bonded to who?
Oxygen.
Okay, I'll take that.
Your calculator. There you go. Or whatever your calculator is. Because. What?
You haven't needed it for math in a while, but you never know. Alright,
That's a 16.
alright, what do we call it?
537.
Ooh, so if I have a larger atom, will I have a stronger London force or a weaker London force? If I have a larger atom.
Weaker.
Final answer? Just making sure, because it's one or the other.
Yes.
Nope, Chris,
Higher.
higher, because if I have a larger atom, I'm gonna have more electrons, so
I
there's
can come
higher
back right
chance
now.
of them
I have 102.
splitting.
I just need to get 2 16s or 3. Where's my darts?
So you just had them.
How many questions do you have left?
Not many. Alright, well, there are two different types. Okay, first of all, what state of matter is it whenever you have the particles are fixed in a definite position? What do you call it whenever, so what state of matter? Whenever they're locked in?
Solid.
S.
Does that matter?
What state of matter?
Huh? I'm confused.
There.
No, don't say it. He should know this. Don't say it. You know he should know this.
Solid?
Yep. That's all I need.
Okay.
Come through.
I didn't know.
It's okay. Woo, not too hard.
Alright, now I have a chance.
There you go.
Alright, what do we call, alright, so there are two different types of solids. What do you call a type of solid that's locked into that repeating pattern?
Start with an A.
It starts with C.
C.
C,
Crystalline.
crystalline solid.
Kobe.
Alright, what's the one that doesn't have a repeating pattern?
Fermorphous.
Furthermore, that's an atom.
Fermorphous.
That's not close enough.
Say it again.
Permophous.
Say it again.
Permophous.
Palmophorous?
Performers.
You're thinking of something else. I don't
It
think
starts
that's
with
it.
P.
Just an A.
It starts with A. Oh, amorphous. Amorphous.
Yeah, amorphous. You got it now. I'm sorry. Alright, what do we call?
14.
What do we call the simplest repeating unit cell in a crystal?
Unit cell.
Unit cell. Alright, what do we call, see I started with crystal, Ethan, one more. Alright, Ethan, what is the simplest crystal to study?
Simplest.
Did she start with you, right?
No, you start with you.
Naya.
Simplest crystals of what?
Yeah, what's the simplest crystal to study?
Solid.
See? It's what 3D shape a dice is.
Crystal? No.
Can't say crystalline. What's the simplest crystal pattern?
Is it my turn?
You're about to be next, hang on.
Snowflake?
No,
Cube.
cubic. So the simplest is the
What do you
cubic
have?
crystal system.
I don't know.
Okay, watch out for my wall.
That was way off.
Watch out for the wall. Okay, 20. Alright,
You didn't win.
I might have gotten close. Or maybe not, I don't know.
145.
I have 151.
I have 125 actually, so.
Alright, even one. Alright, anyone have any questions?
Nope.
Alright,
Okay, quiz now.
Jamie and Quentin, go ahead and pause the video if you study a little bit more for it. But everyone else in the class seems like they're ready to go. Alright, go ahead and take out a piece of paper so I use as a cover sheet. You two gentlemen are close together.
Can I use this?
No. Try. let's see, your packet that I gave, with your parents should have the quiz in it, so go ahead and ask them for it. So if you're reading all the instructions for it, there is a front and back to this quiz. So make sure for this one, you're paying attention, because they only fit so much on that front page. So you have questions 1 through 7 on the front. Don't forget, you have 8, 9, and 10 on the back. So make sure that you're using all of it, and don't just think, oh, it's done now.
We get 20 minutes for this quiz?
I guess you can if you really want to. You probably won't.
Get what? Huh?
Probably
20
won't.
minutes for this quiz.
You
I'm gonna
probably
take the whole
won't.
20 minutes so I can just leave after I take it.
That'd be sad.
For you? You be sad? Why?
I mean, then I'd be worried about your exam.
Even
It
though we
takes you
have
this
a
long
week
to
and
get
a
it
half.
out. Yeah.
We have a week and a half left anyway, so.
Mhm.
Might as well take 20 minutes. Oh, yeah, no, not that long.
Okay, so again, just read through it. Modify true, false. Should you write false anywhere in there, Ethan? Ethan, modify true, false. Should you write false anywhere in there? Alright, what do you change, Chris, to make it true if you feel like it's false? Which part?
The italicized.
Good job. If you have any kids in other grades, try to change the whole sentence. Please don't. Everyone take your eyeballs and look over number 10 before I forget. It's asking which of the following statements best explains why ammonia is polar but boron trifluoride is not. There's only one of those that's the best
Wait,
answer.
what, where?
Number 10. Which of the following statements best explains why ammonia is polar when boron trifluoride is not? So we've gone over that. If you want to draw them out to help yourself see it, that's fine. But there's only one best answer. Some of those are kind of tricky though. Rest of it's straightforward.
What is boron?
Boron is in, it's a semi-metal, it's this one.
What
Group
is
13.
yes, how many does it start with?
I'm not telling you.
Like what is it at? Like what section? I can't see that one.
13. Jamie and Quentin, just so that way it's fair, because you don't have the periodic table. Fluorine starts off with 7, if that helps you at all for it. Boron starts off with 3, if that helps you at all for it. Nitrogen starts off with 5, and then hydrogen starts off with 1, if that helps you. So again, fluorine is 7, boron is 3, nitrogen is 5, hydrogen is 1. That helps you out at all for it. You don't necessarily need it.
Okay. I'm sweating.
time, Ethan? You sure? Alright, go ahead and hand it to me. And then you
What was the last one?
we can't, no, we can't talk about it right now, because Jamie and Quinn might not be finished, so I'll tell you in a little bit though. Alright, what we're gonna do now is we have enough time to watch the lab really quick, so because of that, I'm gonna go ahead and stop for it. Your homework, Jamie, and Quentin, is to just finish up the lab, so you should have enough time, so it's very short. So, the lab, Jamie, so.
I didn't bring my laptop.
Try one in a second. Alright, the lab, Jamie, is lab 14, so that's in lesson 81 in the back of the video. Go over to lesson 81 for crystal structures, that's the lab you want to watch. It's going to take you about maybe 15 minutes tops. So, because of that, switch over to that, and then finish it up for homework. Alright, bye, Jamie and Quentin. Have a good, so again, it's lab 14, it's in lesson 81.